Thank you for joining me on this presentation for Team 69 Deep Learning and Drug Discovery. This project aimed to take an existing project and parallelize it for distributed processing on multiple computers. The original project, I'm not going to get too deep into it, but it basically it's a project that allows chemical scientists to process, it's called lead generation, and it helps them come up with analogs of specific molecules where, for instance, if you need a more soluble molecule, it'll help generate that based on some previously trained molecules. And it stores all those in a giant tree structure. And each molecule has a tree structure, and then it trains a neural network that's then able to generate samples using this model. I mean, currently the project that we started with took a great deal of time in a couple areas. The first area that it took a lot of time in was vocabulary generation. So building up these initial trees that could then be fed into the model as valid molecules took a great deal of time. The second thing that took a lot of time was the sampling of the model, actually getting the results back. Those two things are what we focused on. The other parts of the program didn't take very long, since some work had been done to do some local parallelization on a single machine. So what we ended up using was PySpark user-defined functions. And these user-defined functions let you wrap a block of code that's meant to run sequentially on an individual thread, and it will then package everything and send out messages to its worker nodes, however many you specify, and those process it and process that data and return the data back using that function. We were originally going to use a distributed graph framework that was built from the ground up to be distributed, but that was going to require more knowledge about how the chemistry program worked, and that is outside of the scope of this project, so we left that alone and just focused on doing the overall block optimization. We compared the output of our updated code with the original code using Python's set.difference function. It basically tells you if there's a difference between this set of data and that set of data. It worked to help us debug the software. The speed of the software was measured with Python's built-in timeit library that picked the fastest, most high-resolution timer for a given operating system: Windows, Linux, Mac. The Linux utilities, there's a Linux utility used to measure the resource usage, like memory and cores used for processing. And those were just eyeballed by us, our team, just to make sure that everything was distributing for our distributed software, the updated code. And we achieved pretty good results with this. It ended up being at least 50% faster for almost everything. And keep in mind, this was on one single machine, so it's pretty impressive results. And all of that with only a few lines of code. It wasn't just a few lines of code from the start, mind you, that we had to go through a great deal of debugging to figure out the couple of gotchas that I'm going to mention next. But after all, it was just a few lines of code. Now the gotchas, the things to watch out for are Python class variables. Those do not get captured in the Spark driver thread, the original source thread that sends out the work to be distributed to the other nodes. Those need to be set again inside of each iteration of that user-defined function that gets run on each node. And memory management was a pretty big issue. We ended up um, cleaning up our problems with turning garbage collection back on after we had turned it off for timing, and we'd like to eventually see this code run in the cloud, a cloud distributed network that has more NVIDIA CUDA memory, because we had problems with running out of CUDA memory on our limited resources of our single machine. Python 2.7, which this project was written in, is about to expire in 2020 and needs to be updated to 3.6. We'd like to see better debugging tools for the parallel threads. VS Code didn't seem to implement any way to debug it other than print statements. And we'd like to be able to split up the code chunks more, but we had problems with Python Spark user-defined functions only accepting very basic input and output types like integers, floats, and strings. Thank you very much for your time. Have a good day.